This is R.D. Sharma solution, class 12, chapter 7, adjoint and inverse of a matrix. We are taking MCQs, multiple choice questions. If A is an invertible matrix, then which of the following is not true? Not true. Okay. A inverse, what is the formula? Adjoint A divided by the determinant of A. Determinant of A cannot be equal to 0, so that is true. If you take the transpose and then you take the inverse, it is equivalent to taking the inverse and then taking the transpose. Second is also true. Now take the determinant, take the inverse, or take the inverse and take the determinant. They both are same. We have already seen in the properties. But we have never seen, or we can never vouch for A square inverse is equal to A inverse square. It may be true, it may not be. So this is not the property. All three are actual properties which we have already discussed. So the answer here is first. Now here also we have to find out which is not true. If A is an invertible matrix of order 3. Now let me tell you that which all are true. A inverse of inverse is what? It's a, if 2 inverse is there and you take the inverse of 2 inverse, you get what? You get 2 again back, right? And there are others also which are true, but the answer is third, and I'll give you the reason why it is not true. If BA is equal to CA and B is not equal to C, where B and C are square matrices of order 3. So order doesn't matter actually, let me tell you. So now both sides, let us take, because A is invertible, it is already given in the question. So we can multiply both sides by A inverse. So A into A inverse or A inverse into A is the identity matrix. So B into I is equal to C into I. So whenever we multiply anything by identity element, identity matrix, that will come. B equals C. So B is equal to C, it is coming. If A is invertible, B is equal to C, but the question is saying, the third part is saying, B is not equal to C. If A is this, B is this, A plus B inverse is. Now I would like to take your help, because A inverse plus B inverse you have to find out and then add and then see what happens. One by one I'll tell you the others. The answer is none of these. So this skew symmetric, let us see this one. If A plus B is there and you take the transpose of it, okay? So A plus B, let us take A plus B. 3 plus minus 2 is 1. I'm taking A plus B. It's 1 here. Then 4 minus 2 is 2. 2 plus 0 is 2. 4 minus 1 is 3. Now take the transpose. What do you get? Rows to column. So 1, 2 we are making as a column. 2, 3 we are making as a column. Now we get the original matrix. So when we take the transpose of A plus B, we get A plus B back again. And that is the sign of the matrix or the combination being symmetric matrix. Because if you take X transpose, you get X, you say symmetric matrix. If you take X transpose, you get minus X, you get skew symmetric, right? So it is not a skew symmetric. It is actually, I already showed you symmetric. And that help you are going to give me A inverse plus B inverse, you just find out. And the determinant also I'm taking. Determinant is 3 minus 4. So determinant of A is equal to minus 1. So determinant is there. Okay, so this A plus B inverse does exist. Okay, A plus B inverse does exist. So these first and third I showed you. Second, I hope you'll be able to do by yourself. But the answer is fourth, which is none of these, because all are incorrect except the fourth one, because fourth is actually saying none of these, right? Okay. S is given as this matrix and adjoint of A is. Now the basic method is to find out the cofactor matrix, take the transpose of that cofactor matrix. But I already told you there is a shortcut method. How to do that? See, this is A, B, C, D. Take the diagonal element and exchange it. That is D and A you have to exchange. In place of A, put D. In place of D, place A. This is the first step. Second step is change the sign of other elements. Minus C, minus B. And this is only true for 2 by 2. Please remember. So this is second one. This is the answer. If A is a singular matrix, then adjoint of A is. Let me tell you, A is a singular matrix. That is, determinant of A is actually equal to 0. Right? Now, adjoint of A. So we have a relationship. We've already seen in the questions and properties in previous exercises, A into adjoint A is equal to determinant of A multiplied by the identity matrix per se, and that is of order n. So adjoint of A will be what? Determinant of A. Let us divide both sides by A just to see what we are getting. Now determinant of A is 0. So whatever you take here, adjoint of A is going to be 0. Now let us take the determinant here. See, right one is the null matrix. But when you take the determinant, you get a value. So it will not be a matrix now, it will be 0. On the right hand side, you will get a 0 here. Right? So first one was the matrix and now we have got a value. So when you get a determinant of some matrix as 0, it is going to be singular. That is the theory. If A and B are two n by n non-singular matrices, then, okay, so non-singular matrix, when we have A, determinant of A, this is not equal to 0, that means it's a singular matrix. Non-singular, that means it is not going to be equal to 0. Similarly, the determinant of B is also not equal to 0. Now the expression which I am going to tell you, this is also what we have seen in our discussion. Determinant of A into B is simply determinant of A multiplied by determinant of B. So AB determinant is nothing but determinant of A into determinant of B. Okay? Now, since determinant of A is not equal to 0 and this is similar for determinant of B not equal to 0, so what do you get? Determinant of AB will not be 0. This both the parties A and B, they both don't give you determinant as 0. So determinant of AB will not be equal to 0. So it will be non-singular. A into B is non-singular. If A is this, then the value of adjoint of A, determinant of adjoint of A. So what is the way? So you need to remember what we have already discussed. First thing is, you do proper adjoint, you do, and then take the determinant. This is up to you. But I'll give you, because this is an MCQ, questionnaires we are doing. So there has to be some trick which you need to be applied. So if I take A out from this matrix, you get inside what? That is the identity matrix. Basically, it's a K. K means constant. So this is a scalar matrix. We have taken A, that is a constant outside, right? So when you take this out, the determinant of A for a scalar matrix, any scalar matrix, is simply multiplication of the diagonal elements, A into A into A. So that is going to be A cube. Now, the order, what is the order? This is a 3 by 3 matrix. So order is 3. I told you already that adjoint A, the determinant of the adjoint A, we have already seen in the very short, small answer questions and in our discussions earlier. Determinant of adjoint of A is determinant of A raised to the power n minus 1. Determinant of A is already with us A cube. N is 3, 3 minus 1 is 2. So A cube to the power 2, multiply 3 and 2, A to the power 6. This is the answer. If A is this 3 by 3 matrix, then determinant of adjoint of A. So we have to find out the determinant. So This also, the expression of finding the determinant of adjoint of A, we already seen. Determinant of adjoint of A is simply the determinant of A raised to the power n minus 1 whole square. And what is n here? N is the order of the matrix. Here it is 3 by 3. Right? This type of questions are asked generally in MCQs in various competitive exams. So rather than doing everything, use this trick, use this expression. So let us find out the determinant. I'm opening using the first row 1, 2, negative 1. So 1, it's 1, 2, negative 1, 1. 2, you get negative 1, 2, 2, 1. And minus 1 here, you get 1, minus 1, 2, 1, minus 1. Okay, so this is 1, minus minus become plus 2. So 1 into 3, so it will be 3 here. Then we have the second part or second element. 1 into minus 1 is negative 1, minus 2 to the 4, so it is negative 5. Negative 5 into negative 2 is plus 10. So just write it here, plus 10. Okay, now here also let us see minus 1, minus minus is plus, minus 2 is negative 1, negative 1, negative 1 is plus 1. Okay, so you get 14 here. Now determinant of A we have got, put 14 here. What is n? 3 by 3. So 3 is n. So 3 minus 2 is 2. 2 square is 4. So this is 4 here. 14 raised to the power 4 is the answer. If B is a non-singular matrix and A is a square matrix, then determinant of B inverse A into B. So there are 3 matrices here. B inverse AB. So the answer is third one here. And what are the steps you are going to employ that I am going to tell you just now. But first thing first is, in the question it is already given, B is a non-singular matrix. What does it mean? B is non-singular. That means the determinant of B is not equal to 0. That is, B is invertible and B inverse exists. Remember, it is not equal to 0, B inverse exists, because B is actually invertible, because determinant of B is not equal to 0. Now B, if you take the inverse, if you take the determinant of B inverse, what do you get? B inverse. This is a property. We can take the determinant and then take the inverse. 2 inverse is 1 by 2. You can write 1 by determinant of B. You can always write that. Now coming to this one. So determinant of B inverse A into B. So I told you determinant of A into B is determinant of A into determinant of B. That property we already know. So either you take 3 of them, separate them 1 by 1, or you can take, let us separate first B inverse and AB. So determinant of B inverse into determinant of AB. Then B inverse, then take this AB as A and B separately. Okay. Now what is B inverse? We have already seen this. This is 1 by B, determinant, A and B. So we can cancel this determinant of B and determinant of B, because determinant is a value. So we can cancel it out. We cannot cancel the matrix, but we can cancel the determinant value. So determinant A will come. For any 2 by 2 matrix, if A into adjoint A is this is a scalar matrix, the value scalar is 10, then determinant of A is equal to. So I just told you, and we have already seen A into adjoint A is determinant of A multiplied by IN. N is a subscript and N refers to the order of the matrix. Okay, so what do we have? A into adjoint A we already have. This is already given in the question. So let us equate this determinant of A into I with the matrix which is already given, A into adjoint A. Okay, A into adjoint A is, I am just replacing this A into adjoint A with a 10, 0, 0, 10. And now we know this is a scalar matrix, so we can take 10 common, because this is already given in the question. Okay. So if you multiply I, you won't get the answer properly. So I'm just saying that keep that I, and then you see what we are going to do on the right hand side. Determinant of A into I is equal to, now take this 10 outside. What do you get? 1, 0, 0, 1. So 10 into I it is. So when you equate determinant of A into I equals 10 into I, that is determinant of A is equal to 10. That is going to be your answer. Now here we have A raised 5 is equal to 0. And you can call it as a null matrix also. Also given as A raised n is not equal to I. Then there is a range of n from 1 to 4. So I minus A inverse, what will be the value of that? Before we go ahead, let me tell you, A raised 5 minus B raised 5 is A minus B, along with the term where we have A and B combination. Okay, so in place of A we are putting I, in place of B we are putting A. Why we are doing this? Because I raised 5 minus A raised 5, we'll use this formula. I square, I cube, I raised 4, I raised to the power n, it will always be I only. Or if you multiply by anything, that thing will come. So I minus A, wherever you have B, just put A, and wherever you see A, just put I. But wherever their combination is there, just put A. So I plus A square plus A cube plus A raised 4. Right? Now, A raised 5, it is equal to null. It is given in the question. So we can just write I raised 5. I to the power n will always be I. So right hand side I am taking in the denominator I minus A. Now right hand side. Now I just assume it to be 1. It's actually 1 in matrix form. So 1 by I minus A can be written as I minus A inverse. And that is going to be equal to what? I plus A square plus A cube plus A raised 4. Okay. Now this whole is nowhere to be found, so the answer is none of these. Next one is, if A satisfies the equation, this one, because A is satisfying this equation, then A inverse exists if. So we'll put A in this equation because it is satisfying. Then we'll try to find out A inverse, and then we'll see what condition it should exist. So the answer is lambda is not equal to 0. You will just see how this comes. First, we will satisfy this A with this equation. You have A cube minus 5 into A square plus 4 into A, and lambda I am taking on the right hand side. So it is negative lambda. Now this thing you have to do for many of the questions. Whenever this type of question comes, multiply both sides by A inverse. So because we have to find out A inverse, so in order to introduce also, just multiply both sides by A inverse. You can do A inverse into this, so whenever you multiply A inverse, it should be on either left hand side or right hand side of that numeral or expression. So whenever we multiply A inverse with say A cube or A square, one power will be deducted. So it will be A square. Here 5A plus 4A into A inverse is I. So you may write 4I, or you may just go on with 4. Okay. So this is minus A inverse lambda. Okay. So what we are interested in? A inverse. So lambda I am taking in the denominator, and there is a negative also. So this is lambda. Negative I am saying. So let us write it in negative. A square minus 5A plus 4 and divided by lambda. Now when we have A by B condition, that is only possible when B is not equal to 0. Otherwise that division will be not defined. So lambda cannot be 0. A inverse only exists when lambda is not there, or lambda is not 0. Lambda should not be equal to 0. Okay. So lambda not equal to 0 is the answer. If for the matrix A cube equals I, then A inverse. Now this is very straightforward question. Just multiply both sides by A inverse. Whenever you have A inverse, introduce it yourself. So just multiply A inverse. A inverse with A cube will be A square. anything multiplied by identity will be that thing only. So A inverse equals A square. So this is the answer. First one is the answer. If A and B are square matrices such that, now square matrices and such that B equals negative A inverse B A. So A plus B square we have to find out. And please remember, it is not that A plus B whole square, so that you get A square plus B square plus 2AB. No, that's incorrect. This is a matrix. So AB and BA, they are not same. Okay, it's not commutative. Matrix multiplication is not commutative. So what we have to do here is, as I said, B is equal to this. Now let us multiply both sides by A. Why? Because we just want to get rid of this A inverse. So multiply this A on both sides, here also A. Now AB equals A inverse is identity. So B into A. Now AB is equal to minus B. We'll use it. We'll employ it, right? When we multiply A and A inverse, we get identity. That also you should know. Let us now turn to A plus B whole square. This is going to be A square plus B square plus AB plus BA. Now AB minus B is equal to minus BA. So this is minus BA. You can cancel these two out. It will be A squared plus B squared, and that is your answer here. Second option is your correct answer. Now if A is equal to this, then A raise 5. A raise 5. This is a scalar matrix. So this is A. Let me write it like this. A. I am taking 2 outside for a time being. So inside we'll get the identity matrix 1 0 0 0 1 0 0 0 1. So we can write it as A equals 2I. A raise 5 is take the power of 5 both sides. So A raise 5 will be equal to 2 raise 5. 2 to the power 4 I am taking here. 1 2 I am keeping it with I. 2 to the power 4 is 16 and 2i. Now this 2i is what? You see A. 2i is A only. We have already seen this A is what? 2 into I only. So A raised 5 is 16. This is your 2 0 0 0 2 0 0 0 2, and that is nothing but your, it was A. It is A. So A raised 5 is equal to 16 into A. That is your answer. For non-singular square matrix A, B, C of the same order, A, B inverse C need to be found out. Always remember, we have already seen that A, B inverse is equal to B inverse into A inverse. Now we have 3 matrix here. When we take the inverse, we will start with C, C inverse, then the B, B inverse of inverse, and then A inverse. Inverse of inverse is that same matrix. So C inverse, B, A inverse. What is this one? Fourth one is the correct option. The matrix, this one, is a singular matrix. The value of B is, what is the value of B? Now singular matrix is that matrix determinant value is equal to 0. So we have to find out the determinant. I hope you'll be able to find out the determinant. I'll just show you what you'll get when you open with 5 and 3. But here 20b is cancelled. So you get 60 minus 12. That is 48 equals 0, which is, this is not what we wanted. So B is not existent. There's no B. This is because of this situation. If D is the determinant of square matrix A of order n, then the determinant of its adjoint is, okay, see. So we will use that expression. We have generally seen this in our properties session, but adjoint of A determinant is nothing but determinant of A raised to the power n minus 1. Now determinant of A is what? Determinant of A is D. So I'm writing D here. N minus 1 raised to the power n minus 1. This is the answer. If A is a matrix of order 3 and determinant of A is 8, then the adjoint A determinant. Just seen this question already. Adjoint of A will be equal to determinant of A raised to the power n minus 1. Determinant of A is what? It's 8. What is n? It's 3. 3 minus 1 is 2. So it's 2, but there is no answer like that. So let me write this 8 as 2 cube. 2 cube is 8. We don't have any answer like that, so we have to convert it in the form of 2. So 2 to the power 3 to the power 2 is 2 to the power 6. Okay, this kind of question, the only way is to multiply it by A inverse. Because the question is asking about the inverse of A when this expression is given. So the best way is to multiply both sides by A inverse. Let me do it. A square minus A plus I is equal to, this is null matrix, it is not 0. And let us multiply this with A inverse on both the sides. A inverse, A square is A inverse A is identity element here. You get I plus A inverse I will be again A inverse equals A inverse into null matrix will again be 0 only. So A minus I, you can take A inverse I on one side. So the other side will have this I minus A. So this will be I minus A. Simply A inverse is I minus A. This is what you see in the lower part of this screen. You see A inverse equal to I minus A. I have just made it as A inverse equals to A minus I. I'll just change it because A, as we have taken this on the right hand side, A inverse I will be equal to I minus A. So this is the correct answer. Third one is your correct option. If A and B are invertible matrices, which of the following statement is not correct? This kind of question we have already taken in the initial questions of this exercise. So let me just tell you, A plus B inverse is equal to A inverse plus B inverse is definitely not correct. This we have already seen. I requested you also to solve that question by yourself, because other are the properties. Whether these A B inverse equal B inverse A inverse, we have just done, we have just completed one question like that. So the correct answer is third one. If A is a square matrix such that A square equals I, then A inverse is equal to, this is very straightforward, multiply both sides by A inverse. A square equals I, multiply this by A inverse. A inverse here, A inverse here. A inverse A square will be A, and A equals A inverse. This is your answer. So second is your correct option. A is this, B is this, and X be a matrix such that A equals Bx, then X is equal to. So I'll show you to you here only. So what will be the first answer is the first one. This is the solution. But how did it came? How did it come? Sorry. So A equals Bx. Now multiply both sides by B inverse. What do you get? B inverse B is I. B inverse A equals I into X. I into X is X only. So X equals B inverse A. So we have to find out the inverse of B. So what will be the inverse? First we'll find out the adjoint. 2 and 1 I am replacing. 0, 0 will be negative 0. So it will be 0 only. This is the adjoint. What is the determinant? 2 minus 0. So divided by 2. So this is going to be B inverse. Now this whole has to be multiplied by A. This whole is your B inverse, and this multiplication will give you this result. Calculation, I think you will be able to do it. If A is this matrix 2, 3, 5 minus 2, be such that A inverse is equal to K into A, then what will be K? So this is quite straightforward. I'll just do it here. A inverse we can compute. It's quite easy because this is 2 by 2 matrix. A inverse we'll find out, and then we'll try to equate it with K, and we'll see what K comes, because there will be definitely A coming on the right hand side. If you remember, this question is already being done. So A is 2, 3, 5 and minus 2. And what is the adjoint? Adjoint is exchange this values, diagonal values, so it will be negative 2, 2. Change the sign of 5 and 3, it will be minus 5, minus 3. Now, when we have done this, this is the determinant is minus 2 to the 4, minus 5 to the 15. So determinant is minus 19. So you can just divide this by minus 1 by minus 19, or you can say minus 1 by 19 is multiplied. This is your A inverse. Now let us equate this with A inverse equals K, because question is saying that A inverse is equal to K. Now I'm taking negative outside from this matrix, or you can say multiplying negative inside. So it will be plus 1 by 19. So now I'm equating, what is this? 2, 3, 5 minus 2. This is your original matrix, it is A. So A inverse equals 1 by 19A. So what is question saying? A inverse equals KA. By these two, K is equal to 1 by 19. This is your answer. Matrix. So here we have a matrix, and it is orthogonal. Orthogonal means A inverse is equal to A transpose. So you can write A inverse as 1 by A, and that is equal to A transpose. Now you can take this A on right hand side, that is A transpose into A is equal to D, because these are matrix, so it will be identity. Now this 1 by 3 is a scalar, so you can keep it out both for A transpose and for A as well. So this will be 1 by 3 into 1 by 3, that is 1 by 9. Inside this, we have A transpose here and A here. So let me write this 1, 1, 2, 2, 1, negative 2, x, 2, y. And what is the transpose? Let us make the row to column. 1, 1, 2. This is 2, 1, minus 2. And x, 2, y. Okay. Now let us multiply this. This is identity. This is equal to identity. Let us take this 9 on the right hand side. It is going to be 9i. And this I is an identity matrix. Let me write it 1, 0, 0, 0, 1, 0 and 0, 0, 1. When you multiply this, it will be 9, 0, 0, 0, 9, 0 and 0, 0, 9. Okay. So let us multiply this, and 1 into 1 plus 2 to the 4, and then we have the x into x square plus this. So first row with first column, and this has to be done for all of it. So I'm doing one of it. So x square plus 5 will be. Now first row with the second column. So 1 into 1, 1, 2 into 1, 2, and 2 into x. So it becomes 2x plus 3. Next one is 1 into 2. That will be 2, 2, and 2 into minus 2 is minus 4. So 2 minus 4 is minus 2. Then we have minus 4 it is, and then we have xy plus xy. So xy minus 2 it will be. Okay. Now we'll use, I hope you'll be able to do this matrix multiplication. So all these are checked. So I am just directly writing all the values just to save time. So xy minus 2, 2y here, and y square plus 8. Now let us equate. The first thing fails is 6 is equal to 9. This fails. 6 is not equal to 9. So, and there are multiple x that will come if you equate. There are multiple y that will come. So the answer is none of this. I'll just show you. 2y equals 0. Y is equal to 0 here. Now xy minus 2 equals 0. You get xy equals 2. Now you need to get x and y so that you get 2. Since x square plus 5 equals 9, you get x square equals 9 minus 5, that is 4, plus minus 2x will be. So x is plus 2 minus 2, you have y equals 0. Now you have, I'll show you other values as well. So there are multiple values that are going to come. That only happens when the orthogonality is not there. Because y square plus 8 is equal to 9, y square equals 9 minus 8, that is going to be y equals plus minus 1. So that is why the orthogonality is not there. The answer is none of these. Now this is the matrix. We have to do A into I plus B into A plus 2 into A square. So I hope you'll be able to do the A square, A into A. So this is going to be this one. I'm not doing A into A. I hope you'll be able to do it. And I'm putting it here after multiplying with 2. So 2 into 1 plus A, 2B, 3 to the 6. This is what you see here. So you'll be multiplying 2 with every element. Multiply this A with B and write it here, and you can just write A into I here. That is the scalar A matrix. Now A plus B plus 2 plus 2A, that is going to be 3A plus B plus 2, and you just add each and every corresponding element. You're going to get this matrix. Now this matrix is not in our option. There is no option. So none of these is the answer. Now we have two matrices here, and the second matrix inverse is given. So this is equal to A minus B, BA. So what is A and B? Let us take the inverse. Okay, this matrix and this inverse. So we are going to find out the inverse of the second matrix first. Okay, so let us see this. 1 tan theta minus tan theta and 1. So we are taking inverse here. Let us find out the adjoint. Let us exchange the diagonal values so it won't affect. And now change the sign. It will be tan theta, it will be minus tan theta. This is your adjoint. Now let us divide it with the determinant. What is the determinant? A inverse is adjoint A divided by the determinant of A. So this will be 1. This minus become plus, and tan square theta. 1 plus tan square theta is sec square theta. So 1 by sec square theta it is. So let us multiply now. 1 plus sec square theta, assume it should be scalar, so you can take it out, means keep that side, and now multiply properly 1 minus tan theta, and you see these both matrices are same. First matrix and the second matrix, which we just found, is 1 minus tan theta. This is tan theta 1. Okay, so when you multiply this, I'm not going to multiply this, I leave it for you. But once you multiply, you have to divide the whole by sec square theta. You can say multiply it by 1 by sec square theta. So to get here, these values you get. So 1 minus tan square theta by sec square theta, like that. Okay. Now let us equate this with A and B. So I am not multiplying, I am just telling you the whole result, and now I am equating. So 1 minus tan square theta by sec square theta is A. A is 1 minus tan square theta divided by sec square theta. This is your A. What about B? B is what? 2 tan theta by sec square theta. 2 tan theta divided by sec square theta. Right? Now this 1 minus tan square theta can be written as 1 by sec square theta minus tan square theta by sec square theta. So this is cos square theta, and tan by this sec. Tan can be written as sin by cos. Sec can be written as 1 by cos. So square it is, both are squares. So what do you get? You get cancelled, and finally what do you get? Cos square theta minus sin square theta, and this is the formula for cos 2 theta. Cos square theta minus sin square theta is cos 2 theta. Similarly here 2 tan theta is sin by cos, sec square theta is 1 by cos square theta. You take cos square above, cos gets cancelled, 2 sin theta cos theta you will get. And 2 sin theta cos theta is nothing but sin 2 theta. This is your B. Now you see A and B, the second one is matching, so this is the answer. If a matrix A is such that this is equal to 0, then A inverse equal to. So this A inverse, let us see, this is A inverse multiplied by 3A cube plus 2A square plus 5A plus I, and this is equal to, now multiply with A inverse. A inverse into 0 is what? It is going to be 0. Now A inverse multiplied by A cube, what do you get? A square, 3A square, plus A inverse with A square is A, 5A to A inverse is I, and plus A inverse into I. Now this right hand side is 0, so you can take this A inverse I on one side and others on other side. So you'll get A inverse as negative of 3A square plus 2A plus 5I. So 5y is this, you can write as 5. So the answer is the first one. No, the first one, 3a square plus 2a plus 5. If A is the invertible matrix, then determinant of A inverse is equal to. Now A inverse you have to find out. A inverse is what? 1 by, you can just write it as A inverse is 1 by A. So determinant of 1 by A is 1 by determinant of A. It's straightforward. This is your answer, right? Second one. So this is how you have to do it. Now A is this matrix, A is n, you have to find out. So n is an even natural number, n is an odd natural number. You'll just see what we get. We'll try it for A square. This is 2 minus 1, 3 minus 2. So this is A. A square you have to multiply A with A dot A. So A multiply it, 2 minus 1, 3 minus 2. So 2 into 2 is 4 minus 3. Now 2 into minus, now first row with second column. 2 into minus 1 is minus 2 and minus 1 minus 2 is plus 2. 3 into 2 is 6 and 3 into 2 is minus 6. 3 into minus 1 is minus 3 and 2 to the 4 is plus 4. So what do you get? 1, 0, 0, 1. That is the identity matrix. A square is identity matrix. So square means it is even power. So we can safely say that A raised n is equal to I if n is the even natural number. Now I would like you to try A cube as well. That is, you can multiply this whatever result we got I with any of the matrix. When you multiply A square with this whole matrix 2 minus 1 3 minus 2, you'll get the same matrix. When you again multiply this with the same A, you'll get again the identity matrix. I hope you got the idea. So this is how it works. So finally you can say that if it is even natural number, an is I. If x, y, z are non-zero real numbers, then the inverse of matrix A. So matrix, let us take the inverse. We know that how do we do it? A equals I into A. This is how we do it. So A equals IA or A equals AI, and then we try to make this A on the left hand side as I. So I on the right hand side automatically becomes the A inverse. So I'm writing A here. This is A, and on the right hand side, let us write the identity matrix 0, 0, 1, A here. Okay. Now we have to take this left hand side and we have to make it as the identity matrix. So this right hand side will become say inverse all by itself. Okay. So this one, let us multiply the row 1 with 1 by x, row 2 with 1 by y, and row 3 by 1 by z. And this has to be done on the right hand side as well. So what do you get? 1, 0, 0. Here also 0, 1, 0. Here 0, 0, 1. So you get an identity matrix here. And when you do this here, 1 by x will come because you're multiplying it by 1 by x. Here 1 by y, 1 by z. So how do you write 1 by x? You can write it as x inverse because the question is saying that. So you can write it as x inverse 0, 0, 0, y inverse 0, 0, 0, z inverse. Okay, and this is your A inverse. So you can just check this answer. This is your answer. First one is your answer. Okay, this is all about this MCQ. Thank you so much. Take care of yourself.